Okay, this is a video that I'm making to support a college algebra class that I'm taking, as well as some other Algebra 1, Algebra 2 high school classes in my building. In addition, we're going to cover a couple of topics that are specifically useful to calculus students when they are attempting to find the equation to a tangent line, which we have just recently covered in Chapter 3 of our calculus textbook. So if you're here for that, you may want to skip around to find where we're talking specifically about the point-slope form. That's going to be more useful to you than the rest of this. So with straight lines, we have a couple of different ways of representing the equation for a straight line. And perhaps the most friendly and common one that we all know and love is this guy right here. This is y equals to mx plus b, which is also known as the slope and intercept form. Now what's nice about the slope-intercept form is that it gives us a nice easy point on the graph with which to plot, and then it gives us a set of instructions to follow to produce a graph. So I'm going to show an example of this form in action. First, one of the issues with this, however, is that if we do not know the slope or we do not know the y-intercept, then this may not be the most natural form to use in order to produce an equation. We may need to use something slightly different to get a workable equation before we worry about making it pretty. But when everything is nice and pretty and the problem gives us a slope and a y-intercept, then mx plus b is extremely, extremely easy. So notice that finding an equation of a line where both of those things are given, really all I need to do is first recall one of the formats for the equation of a straight line. In this case, I'm going to pick a format that is the closest to the information that I was given. Mx plus b gives us the slope and the intercept. So all I need to do is replace the slope and the intercept with the numbers that I've been given. So we know that m represents the slope of a line and b represents the y-intercept of a line. Now, a special note that I had to deal with the other day, which I actually thought was kind of an interesting misconception, was that the slope number is pretty obvious what you need to do. If you plug in 4 for m, then we get 4x. But then there were some students in an Algebra 1 class who were trying to keep this sign that is attached to the plus b form always positive. So they were writing this equation plus minus 3. And I can see how if you are a teacher in a high school, or if you're trying to help somebody with a high school problem, that might cause issues if they're using a TI calculator. Because if you attempt to enter something 4x plus minus 3, and typically students who do this are also kind of the ones that will key it in wrong. And this is just from personal experience. It's not necessarily proof for this. But what you'll notice is you'll get some kind of error in the calculator. And that is because of the negative symbol actually being a different key in the calculator. So I thought this one was interesting. And this was actually not my own. I didn't actually have this student myself. But I thought it was an interesting misconception when it was brought to my attention, so leave any thoughts that you have in the comments. So what I did to fix this is that this could be plus or minus b depending on what you're given. If you're given a negative number, you use the minus sign. If you're given a positive number, you use the positive sign. So of course this should ultimately end up being y equals 4x minus 3. Now graphically, this is very nice. Graphically, the y-intercept number on this form kind of gives us the first point we should plot. So minus 3 literally says on the y-axis, let's go to where minus 3 is and put a dot. And so I like to think about this guy like it's the starting point and the slope like it's the instructions that you're following. So now that I've got my starting point, I'm going to follow the instructions to produce the next point. And slope is in rise over run format. That is rise over-run format. That's what the slope is. So if you think about that, 4 could be written as 4 over 1. So that tells us to go up 4, the rise, up 1, 2, 3, 4, and over 1, and plot our next point. I had to grab a straight edge, I apologize. All we have to do at this point, connect it up, and there's my straight line graph. Now that's fantastic. What happens, however, when we don't know necessarily what the slope is and what the y-intercept is? Well, here I've been given a problem that says we're going to find the equation of a line that has x-intercept -2 and y-intercept -2 as well. Now this one's really interesting because we might start with a graph before we do anything else, especially since we know the y-intercept. So in this graph, we have a dot at -2 because the x-intercept, the place that it crosses the x-axis, is -2 right here, where I'm going to put a little dot there. And then the place where it crosses the y-axis is also -2 down here. Put a little dot there. So graphing these things when you know x and y-intercept is actually even easier than writing the equation for it. It's easier, but that's about the only thing that's easier, is graphing it. Now we have a couple of different forms that might be useful here. For example, we have our double intercept form, which I might derive it in a later video. This video is already getting pretty long, so stay tuned for that. But we have an issue here in that I do know b from my mx plus b form, but I don't know what the slope is, at least not right away. So what we can do is we can follow our formula to find the slope. As long as I can produce an ordered pair for each of the numbers that I've been given, then I should be able to calculate what the slope is. I'm going to do this once with the formula, and then I'm going to do it once kind of a tricky way. So I know that the x-intercept is the place where the y value is 0. That means that an x-intercept of -2 corresponds to -2, 0. And a y-intercept is the place where the x value is 0. So a y-intercept of -2 corresponds to 0, -2. Now here we have our slope formula that we need to remember. And so we're going to recall that the slope formula is y2 minus y1 over x2 minus x1. Now in general, the word recall means this is something that we're supposed to have memorized, or it's something that we're going to go look up to see the general format of before we start plugging things in. It is always my suggestion to students that they actually write the formula that they are using so that they can reference back to it and know if they've plugged everything in correctly. Now, we can call either of these x1 or x2, it doesn't much matter. I'm going to call these, this is the first ordered pair and this one is the second ordered pair. Now the reason that I'm writing this is that you'll notice that we have these little subscripts here. We got y2, x2. I'm going to use the second ordered pair to fill in x2, y2. So y2 is -2 and x2 is 0. Now I have a subtraction that is inherited from the formula. And then I'm going to use the first ordered pair to fill in x1, y1. Now, y1 is the y coordinate from the first ordered pair, that's 0, and x1 is the x coordinate from the ordered pair, which is -2. Simplifying this all out, we get -2 over +2, which gives us -1 as our slope. Now once we've got our slope, it's pretty easy to recall again the equation for a line, y equals to mx plus b. So I'm going to fill in the slope with the slope. That's -1x. And then the b part, I should write this as plus minus since I made that a point earlier, excuse me, The B portion is the y-intercept. Now don't get confused when you have both an x-intercept and a y-intercept. Make sure you're taking the y-intercept. In a way, I don't want to say that this one is more important, but you can draw some little stars or something near it to know that in a way it is a little bit more important than the x-intercept. So we're going to take the y-intercept number, which is -2, and stick that on the end of our equation. We can simplify this a little bit. There you go. There's an equation for the line. Okay. So I think that about covers your slope-intercept form pretty well. And it also covers your slope formula pretty well. Now it is important to note that although this formula can be used, and of course this is going to make some Algebra 2s and even calculus students mad, this is not the equation for a straight line, at least not if you're an Algebra 1 student. Okay? So this is not the equation for a straight line, this is just a formula that helps you figure out what the slope is so that you can go back and plug it into either the first form, second form, or the third form, just depending on which one you're using.